Here's a reading of section 3.2, percent composition of compounds. The formula of a compound indicates the number of atoms of each element in a unit of the compound. From a molecular or empirical formula, we can calculate what percentage of the total mass is contributed by each element in a compound. A list of the percent by mass of each element in a compound is known as the compound's percent composition by mass. One way that the purity of a compound can be verified is by comparing its percent composition by mass, determined experimentally, with its calculated percent composition. Percent composition is calculated by dividing the mass of each element in a unit of the compound by the molecular or formula mass of the compound and then multiplying by 100%. Mathematically, the percent by mass of an element in a compound is expressed as, and now let's look at equation 3.1. Percent by mass of an element equals N times the atomic mass of the element divided by molecular or formula mass of the compound times 100%. So if you recall, back in the previous section, 3.1, we looked at how to calculate the molecular mass of a compound or the formula mass of a compound. So we're going to use that here in the denominator of this ratio. And then in the numerator, we're going to take the number of atoms of the element we're interested in. So let's say, for example, we're interested in hydrogen. If there's 2 hydrogen atoms in the formula, we would write N is equal to 2. Then we would multiply that by the atomic mass of the hydrogen, divide that by the molecular mass, and then multiply by 100%. So let's take a look at an example here. It says where N is the number of atoms of the element in a molecule or formula unit of the compound. For example, in a molecule of hydrogen peroxide, H2O2, there are 2 hydrogen atoms and 2 oxygen atoms. The atomic masses of hydrogen and oxygen are 1.008 and 16.00 AMU, respectively. So the molecular mass of H2O2 is 34.02 AMU. Now, they don't show you how to get that, but that's something we learned how to do in the previous section, right? 34.02 comes from the fact that there's 2 hydrogens, each is 1.008, 2 oxygens, each is 16.00. So if you multiply those together and add them, you'll get 34.02. Therefore, the percent composition of H2O2 is calculated as follows. Percent hydrogen equals 2 times 1.008 AMUH divided by 34.02 AMU H2O2. So the 34.02, that's the molecular mass of H2O2. We're doing hydrogen first. The top calculation is hydrogen. So 2 times 1.008 AMU for hydrogen divided by the molecular mass, 34.02 times 100, and you get 5.926%. Now, try not to get too hung up on the significant figures, but take a look at what happens here. In the numerator, hydrogen has 4 sig figs, 1008. And the formula weight, the molecular mass, is 34.02. So that also has 4 sig figs, 3402. So both numbers have 4 sig figs. When you do division, the answer has the same number of sig figs as the one that has the fewest number of sig figs. Since both of those calculations, numerator and denominator, has 4 sig figs, the answer would also have 4. So 5.926%. Now let's do the same calculation for oxygen, percent O. 2 times 16.00 AMU for oxygen. Remember, we're looking up those values in the periodic table. Divide that by 34.02 AMU for H2O2, that's the molecular mass. Multiply by 100, and you get 94.06%. So you should try that in your calculator. Make sure your calculator is next to you and try each of those calculations and see that you're going to get 5.926 and you get 94.06. Now, the sum of the percentages, 5.296% plus 94.06%, are equal to 99.99%. The small discrepancy from 100%, meaning the small difference from 100, is due to rounding of the atomic masses of the elements. We rounded the atomic masses when we did these calculations, so it didn't work out exactly to 100, but it's pretty close. We could equally well have used the empirical formula of hydrogen peroxide, which is OH for the calculation. So if someone told us the empirical formula for hydrogen peroxide is OH or HO, we could use that as well. And we get the same answer. And that's an important point, which is if you have the molecular formula and you have the empirical formula, you will get the same percent composition by mass. So in this case, we would have used the empirical formula mass, 17.01 AMU, in place of the molecular mass. So percent hydrogen equals 1.008 AMUH divided by 17.01 AMU times 100%. And that would give us 5.926%, sorry. And the percent oxygen would be 16.00 AMU for oxygen divided by 17.01 AMU times 100, which would give us 94.06%. Because both the molecular formula and the empirical formula tell us the composition of the compound, they both give us the same percent composition by mass. Sample problem 3.2 shows how to calculate percent composition by mass. So you're going to try that sample problem point 3.2. There is a separate video for that. And then you can also do the practice problems A and B. And then you can also do the checkpoint 3.2, section 3.2, percent composition of compounds. Do both of those as well. Okay?